What's up? What's up? Howdy. If you are here for pre-dental, you need to go to the room next door. If you are here for Dr. Lee's exam review, then you are in the right place. So how this will go, I'm Jess. I'm the TA for the class. You might have seen me sitting in the lectures. I'm always there to answer questions after class if you need or anything like that. And I will first go over the practice problems for this exam, and then it'll just kind of be open-ended questions. So if you guys have any specific questions about homework assignments or questions or concepts that we've covered in class that you want to go over again, then we can talk about it. Any questions? Cool.
Said on one of the lectures, he said it's about traffic. One day,
The stuff today, definitely not exam, but like being able to recognize an alcohol in general, yes, will be on the exam. Okay. So first question on the practice problems were utilization of atoms. What do we need? What's important about it? Yeah. And an easy way that we can figure out hybridization is by counting. So looking at this atom, what is implied that should be explicit when we're looking at bonds? A hydrogen. So we can draw in our implied hydrogen, make it explicit, and now we can just count our bonds. So we have one bond to our hydrogen. We have one bond. Another bond. And when you're doing hybridization, you can count it as less as one. This two. This three. And four. So we have 3 sigma bonds here. So what is the hybridization? FP2. Questions on that one? Cool. So now we can break down those bonds into sigma and pi bonds. What is a sigma bond versus what is a pi bond? And pi bond is anything beyond that. So how many sigma bonds do we have here? 3. We have 1 to the hydrogen, 1 to a carbon, and 1 to the other carbon. Do we have any pi bonds? How many? 1. This we have 1 pi bond and 3 sigma bonds. So the correct answer here is anyone? C. Okay. Electronic geometry around the atom at position 5. What do we need to think about when we're talking about electron domains? Does this carbon have any non-bonding pairs? Yeah. So we have 2 branches coming off of our carbon, right? We have the nitrogen and we have kind of the rest of the molecule. When we have those 2, what is our geometry then? Linear. Okay. Yeah. It's an artifact of the way it's drawn. It's easier to differentiate bonds, especially in a skeletal, by the bends. And so sometimes when you see something drawn like this, it's less clear that that is 1, 2, 3 carbons. So that's why it has a bend to it. Okay, molecular geometry around the atom at position 3. What do we take into account here that we weren't before? 2 lone pairs. So we have 2 lone pairs, but how many bonding pairs do we have? 2. So if we weren't thinking about our electrons, what would we label this as? Linear. But have you ever tried to hold 2 negative sides to each other? They repulse. And so these electrons are going to push us. Any questions?
So what was the, what compound?
Tetrahedral, because you have 4. Okay. So how many carbon atoms are in this molecule? Where would you start with this kind of question? Any thoughts?
Typically try to draw.
Yeah, you can just number them if you want. So we have 1 here. There's not really an easy way to do this. It's just count them. So what is the definition of a primary carbon? It's attached to 1 carbon. How many of those do we have here? So we have this one. Does that show up for that? Does anyone disagree with these? Okay. Yes.
No, it's not.
It is only connected to nitrogens and hydrogens. So that one is not. No, isolated, 0 is. Okay. How do we define our secondary carbons? Attached to 2 carbons. Now, can we consider sp2 carbons in our count?
Yes.
You sound. So could you consider any of these ones in the ring? So we wouldn't consider these ones because these are sp2 carbons. And when we're looking at this, we're looking at sp3.
So. There's still only.
They have different reactivity, especially the ones in the benzene.
So if they're in the benzene.
I think the main point with primary, tertiary, secondary carbons is we're wanting to learn how to identify them now because we'll talk about their reactivity later when we're doing organic reactions. But benzenes are part of an aromatic system, and that's a whole other beast that we'll get to. So, secondary. Who can spot some in this structure? They're all numbered, so they should be relatively easy to call out. Seventeen is one. 16 is definitely. Are there any other ones? No? Yes?
Would that be one?
9 has how many carbons attached to it? 3. So it would be a tertiary carbon. 4 and 8 are part of the benzene. So we put.
Would you call 13?
It is also part of a benzene ring. So we have our primary, our secondary, tertiary. How many in which one? Number 9. And that is our only one. Are there any quaternary carbons in this? Carbons that all 4 of their bonds go to another carbon? No. How many hydrogen atoms are in this molecule? I'm hearing 21. Does anyone have any other answers? No other answers or no answers to add? Okay, let's find out. How many hydrogens would carbon 1 have? Why? Because it's full. What about number 2?
17.
What about number 3? What about number 4? What about number 6? Number 7? What? What about 8 and 4? 0. 5. Does our oxygen have any? No. What about number 9? 10. 11. 12. 13, 14, 15, 16, and 17. 2 each. What about 18? 20 and 19 each have how many? 3. $2100. Okay. Questions there? It counts towards a different carbons, but you wouldn't consider that your central atom.
So this. This.
So like number 5 can see number 4 as a neighbor, but we would never look at number 4 as its own central carbon.
Okay.
And that's only in aromatic hydrocarbons.
It's sp2. Okay, other questions? Yes.
So. What's like primary, secondary, tertiary.
And how many carbon neighbors?
Like because like benzene rings already.
You would never be asked for the central atom in a benzene. Okay. In ethene, the first bond between the carbon atoms is formed by overlap of blank orbitals. The second bond between the C atoms is formed by overlap of blank orbitals. Does anyone feel confident that they know what ethene is and want to draw it? Let me just draw it anywhere here. The first bond is what's the other? So, anybody have any guesses about which answer is right? What is the hybridization of these carbons? sp2. So if the hybridization of this is sp2, and we know that the secondary bonds are pi bonds, any thoughts on what the answer here is? D. Because our second bond is coming from our pi orbital. So it's our p hybridization. And then we have the hybridization of our overall carbon. So, questions on that? Number 12. Which of the following diatomic molecules contains the bond of greatest polarity? What is the real key difference that we're looking for here? Electronegativity. So if something is bonded to itself, is there going to be a great difference in electronegativity? Yes, no, no. So we can knock out quite a few of our answers here because there's not really going to be any difference. So we're left with two answers here. What's the difference between these two? F is more electronegative. So it will be the greatest polarity difference with bromine. What's an easy way to get a general gauge on electronegativity when looking at your periodic table? To the right and up. Okay. Which of the following is the correct condensed structural formula for 2,3,4-trimethylpentane? How much information can we get from this title? Everything. Yeah. That is right. That is a right way to get to the answer. So what does the 2,3,4 tell us? Positioning. And the tri tells us how many methyls. Methyl tells us how many carbons are in our alkyl substitution or substituent. So we've talked a lot about alkanes, alkenes, alkynes. When that carbon chain is a substituent of something else, it's called an alkyl. And so that's where you get the ending of the YL. Hence tells us that our parent chain has 5 carbons, and the A tells us that it's all single bonds. What are the other options that could be where the A is? E and Y, and what do they mean? So we come here and we figure out which of these has a 5-carbon parent chain. 1, 2, 3. So this one could work. This one could work. We can eliminate choice C because that is a 7-membered chain. We can also eliminate choice D because that is also beyond. Now, we're left with these 3. Well, we can look at this one. How many side chains do we have? 3. So this has 3 methyls. This only has 2. So we can knock out that as a choice. And this one has 3. Now, are all of our substituents on the same carbon? No. So this one is also wrong. And we're left with E. Questions on how I got here? Okay. Write the molecular formula for trans-2-hexene. What is our equation for alkenes with a single double bond? Yeah. And we have only 1 double bond here. So how many carbons does hex mean? 6. So we have C6, H12. Would our molecular formula change if this was cis 2-hexene? No. Okay. Draw. Oh, this got changed, right? What does it say on Canvas now? Okay. Trans 2-hexene. So we're just drawing, we just had. Where do you start with this kind of question? 6 carbon chain. What's the next piece of information we can get from it? Double bond and its location. So we have 1, 2, add our double bond. Is this molecule already drawn trans? If it were cis, it would look like this. Do you guys follow the difference?
Yes, I was gonna ask, I guess it's more of just like the fine detail, but does it matter if, when you draw, like, the trans with the double bond under?
No.
Rather than.
No. But so we have this goes down, this goes up, and in this one they both go up. Any other questions? What is the relationship between the pair of molecules below? What is absolutely needed for a cis-trans isomer? A double bond. Is there a double bond in this? No. Are they identical? No. So what's the difference between the answers we have left? Do you think these are unrelated molecules? Why?
They have the same.
Sorry.
So conformational versus constitutional. Any guesses on which way to go?
Conformational, like shape. The overall shape.
Yes. So I'm trying to find a visual that will maybe help. Conformational is going to be like the same connectivity, but different spatial positioning. So do you guys know what these wedges and dashes mean?
Yeah.
Yes. So this basically means that one of the methyl groups is coming towards you and one is going back into the pore. So a conformational isomer could be if the chirality of one of those changed. So if they were both facing towards you or both facing the pore. Get there. Constitutional isomers is going to be when they have different connectivity. So are these methyl groups in this one? You would say that they're connected. as 1 and 2. And then this one, they're 1 and 3. So do they have the same connectivity? They're not connected at 1 and 2. They're connected at 1 and 3. So they're constitutional. A conformational isomer of this one these would be conformation.
Would be the sister.
We'd need a double bond. I can try. So this is getting into the 3D aspect of chemistry. And we haven't fully gotten to explaining like enantiomers and stereoisomers. So right now it's just thinking about how it's different in the 3D sense. So in the first structure, the one that Dr. Lee gave you, this one, you have one methyl that's facing you and one that's facing away from you. A conformational one would be a conformational isomer of this would be both of them facing you. Yeah.
So are the original and structural isomers like restricted, then they don't relate. So you just don't know.
They relate, but they are more commonly thought of in two. Yeah.
So let's say. American, but one, it's still that would that be considered a conformation once they have the same thing, but different. Well, yes.
So those two are conformational.
Okay.
Did that help or no? Okay.
Those two next to each other that have this short area of what?
Then.
So the constitutional ones, they have different connectivity. So you can think of
They saw it.
Yeah.
Dash and line next on it.
Yeah.
But doesn't that matter? The three.
These would be constitutional of the
There's actually.
Did that help or no?
Yes, that is.
That would make like know your hybridization and being able to label primary, tertiary, secondary carbons. Okay. More isomer questions. What is the relationship between the pair of molecules below? Do we have anything in the 3D here?
Because we.
Turn it off. Do these have different connectivity? Like has a methyl group? Are they identical?
No.
No. They are related. So. These are cis trans isomers. We have our double bond here. And in this one, we have one down, one up. Both of them up.
Yes.
And everything else is the same. Questions on that? Yeah.
So why wouldn't that be?
Because of the double bond. So double bonds are not flexible like a single bond is. When you have a single bond, you can have in 3D, but with a double bond, you get more planar results where it's going to be either they come the same way or they do not.
So basically, a conformational looks like a cis trans, but doesn't have a double.
Sort of. Yes. Other questions? Okay. Consider the element chlorine. How many protons does chlorine have? 17. And how do you know that? Periodic table should be your answer because you won't have Google on the test, but you will have periodic table. Okay, I like that answer more. Yeah. Okay. So provide the ground state electron configuration of chlorine. What does a ground state electron configuration look like?
It's all that long.
Yes. So where do you start? There's two right answers here. Yeah. 1s. 2. What's next? 2s. What's next? 2p6. What's next? 3s2. What's next? 3p5. Who knows of a shorter way that we can write this? Yes, you can start with the noble gas. So what's the noble gas? Neon. Neon gets us to what point in our chain here?
It gets you up to 2. Or up to 2.
Yes. So then. What is the most common ion of chlorine? Cl. Which means how many electrons are there? 18. We've added an electron. So what do we change about our configuration? We're not going to write it like that because this is a carbon. Yes, so 3p6. Questions on that?
Yeah, that's what I meant. I just didn't know.
Okay. Are we ready to look at this one? Okay. How many primary carbons are there?
2.
Which two?
The 2 at the bottom.
The 2 at the bottom. Yes. How many secondary? 4. We only have one carbon left. Is it tertiary or quaternary? This is not a benzene, this is a cyclopentane. Benzene is going to be a 6-membered ring that has three double bonds in the ring. It's aromatic, which is not something we've covered yet, but is important fact about it. Yes, it's quaternary. Okay, now we're gonna name it. Where do we start when naming an organic molecule? Parent chain. What's our parent chain here? Cyclopentane. What substituents do we have? We have fluoro. What else? Dimethyl. Where would you start counting? Alphabetical priority is how you order them in naming. We want the lowest number. So is 133 lower or is 113 lower? 113. So we have our 1,1-dimethyl and our 3-fluoro. What order do they go in? Now that we have their positions. Alphabetical. So fluoro comes first. 3, 4. There also shouldn't be a space between methyl and cyclo. So our final name for this is 3-fluoro-1,1-dimethyl cyclopentane. Yes. That's everything from the practice problems. If you guys have general questions, I can answer them. But it's 11 multiple choice questions and 5 short answers. Yeah. Yeah. You can do either. Yes. Yeah. Yeah. I'll be grading it. So I will give you partial credit.
Yes, like the definition of sigma. So sigma is like your initial connectivity, and then pi bonds are bonds.
Okay.
So like a double bond will have one sigma and a pi bond, and a triple bond will have one sigma. What's up? Get the naming stuff down now. So like learning what methyl, ethyl, or like all of your prefixes, and then the like common names that we talked about, so like iso and neo. And then the Zen stuff, so like I focus on the Gen Chem that's covered in the practice problem. So like talking about polarity and hybridization and like electron. What's up? I just want to go on. Yes. So this one, yeah, that's right. Okay, so it's kind of carbon other attack.
But I guess.
This one, you're missing the implicit. Okay. What's up?
Would you mind explaining again about the benzene rings, about like why?
Give me 1 second.
One of those that.
Stop recording.
It was helpful, I'm glad I made, glad I finished my, my essay.